right. Here we are, you guys. Word problems. Yay. And word problems involving factoring. Okay, here we go. So for our viewers at home, I'm going to read this again in case there are things that we cannot read. Okay, a farmer increases the length of a square pasture. I want you guys to be getting some visuals going in your head. I'm going to ask somebody to come up and draw a picture of what the original pasture started out looking like. Then, so a farmer increases the length of a square pasture by 15 meters and decreases the width by 5 meters. The new pasture has an area of 1,125 meters squared. Find the dimensions of the original pasture. How many people think if I asked you to come up and draw a picture of what the original pasture looked like, you could do that? Based on what it says. All right, who wants to come up and draw it? Michael, come up. Everybody give it up for Michael. He makes his way to the stage. Okay, so go ahead and draw it. Leave a little space, but draw it underneath the original pasture. Okay, how many people would agree that that looks pretty good? Clap if you agree. Okay. Now, the question that I have for you guys is this supposed to be, well, let me ask you, square, rectangle? Square. How do you know it's a square? Okay, what? Okay, no, as far as, does it say something in the problem that would indicate that this should be a square? Yes. It's a square. Making sure you're all paying attention. That's good. Okay, so the length of a square pasture. So what is a property of squares that might be helpful to us in this problem? Okay, all sides are equal. So, since we're trying to find the dimensions of the original pasture, can somebody tell me what might help us as far as this goes? One side is the square. Okay, one side is the square root of the area. I like that. Give it up for Chaz. Somebody pick a letter that can represent one or all of the sides here. A, X, L, M, J.
I agree with J.
So you're going through the alphabet. Okay. All right. I'm picking. Since it's a square, we'll call it S. All right. So is that a good representation? If I put an S on all sides here, is that true?
Yep. Yeah.
Because it's a square, right? Okay. Now, the next part. The new pasture, it says over here that this pasture, this square pasture, has a length that has been decreased by 15 meters. So from here, a length that has been increased by 15 meters and decreased width by 5. So how many people think they could take this and like morph it in some way to make a new pasture and draw that picture of what the new pasture is supposed to look like? Don't worry about the letters or anything yet, but what do we think? Lydia, you want to come up and do it? Come draw the picture? What it should look. Everybody give it up for Lydia.
Yeah. We're such a spirited class. Yeah.
I think we're all running low on energy.
Does it matter which Thursday?
Well, yeah, don't label anything. Just draw the picture of what it should look like. Shh. Okay, guys, keep it quiet, please. Everybody is deciding whether they agree with the picture that Lydia is putting up here. How many clap if you agree with that picture? In some way. All right, cool. That's a rectangle. So, up here it says the length of this should be increased by 15. How can I represent that on the drawing that Lydia just put up here? How can I put that up? Haley. Okay, S plus 15. Everybody give it up for Haley. Now, does it make sense to put the S plus 15 along the longer sides or the shorter ones? Why? Because it's longer. Yes. Logic. That's good. Okay. Next. What would go along the other sides? Kendra? Why S minus 5? Because it's decreased by 5. Excellent. Everybody give it up for Kendra. Okay. Now, so these are the key pieces. It says up here that the new pasture has an area of 1,125 meters squared. So that's this one. This has an area of 1,125 meters squared. Okay, who can remind me, how many people remember how to find the area of a rectangle? What do we do? There's something that we're supposed to do. Hannah? Good, length times width. So in this case, so let's say this. Length times width. Everybody give it up for Hannah. Okay, so somebody start filling this in for me. Length times width equals area. We need to plug something in for the length, for the width, and for the area. Ashley G. Pick one of them. Doesn't matter which.
Oh, I will preserve him for Jade.
Oh, Jade.
Okay.
That was nice.
S plus 15 M for length.
Okay.
And then for width, multiply S minus 5
Good.
for M, and then equals the 1,125 meters.
Cool. Everybody give it up for Jade / Ashley. Okay. Now, what do we think? We spent yesterday solving these kinds of problems. There was something that needed to happen. These problems always needed to equal what? 0. Anyone have any ideas about how we can do that? Rachel?
Foil.
Ah, good. Foil. Nice. Everybody give it up for Rachel.
Yeah.
So, foiling, so everybody watch here, because this is how quick you want to be at these. Mr. B is back next year. He likes, like, turbo warp speed, like super warp speed. So here's how quickly you want to do it. Ready? I'm just going to put up here what it's supposed to be. S squared plus 10s minus 75 equals 1,125.
Where does the M?
What?
Never mind.
So, where did that come from? Stacy. Go ahead. Okay. Because the zero product property, the question was, why do we want to make this equal to 0? Actually, let me open it up to you guys. Why do we want to make it equal to 0? From yesterday. There was a property that we were using that allowed us to find any missing variables that we had. So if we look at Lydia. Yeah, what S could equal. But Jared?
Okay, so when you assume it's equal to 0, it means like something, the variable in there has to like multiply, anything multiplied by 0 is 0.
Right.
So we can find out what the variable is by basically using the other numbers in there to balance it.
Okay,
so
good.
That equals 0, so that multiply that to 0.
Good, that's a very good explanation. Everybody give it up for Jared. Okay. Anyone else have another way of explaining it? Stephanie? Yeah. Okay, would you agree that a rectangle, the opposite lengths are the same sides? Or the opposite sides have the same lengths? No, that's okay. Kendra. Ah, okay. With foil, you do the first ones are s squared, the last ones are negative 75. What you're doing to get this 10s is you do the inner and the outer combined. So 15s minus 5s is 10s. That's a quick way of doing it, by the way, is you do the first ones, the last ones, and then do this plus or minus that. Other questions? Marcy. Okay. Foil is first, outer, inner, last. Shh. So here's the quick way of doing this. You do the first ones. S times S is what? S squared. The last ones. 15 times negative 5, that's negative 75. So that's what's in the first and the last spots. To get the middle one, all you do is you take the two inner ones, multiply them together. So get that in your head. What's 15 times S? 15S. And then you're going to combine that with the outer two. So 15S and then negative 5 times S is negative 5S. So 15S minus 5S is 10S. Does that make sense? Okay, so try getting that visual in your head from this point on. Okay, so if I want to get this equal to 0, what do I have to do? Okay, so s squared plus 10s minus, what does that come out to? 1,200. Okay. How do we go about solving this from yesterday? Yeah, use the diamond.
Yeah, those are really big numbers.
Those are big numbers, true. Now, what would happen? Let me just work with me here. What if I got rid of the zeros on there? Can anybody think of anything that multiplies to negative 12 and adds up to 1? Jared?
Oh, 4 negative 3.
Good. 4 and negative 3, but we obviously don't have negative 12. We have negative 1,200. So what can I do to these to get zeros? That's a little trick to help you when you have larger numbers like that. Does that make sense? Yep. Because this is a multiplication, so 40 times 30 is 1,200, and then if adding, you're just dealing with the 1. Does that make sense? Okay, so then we have s, so s plus 40, s minus 30 equals 0. Okay, if we were to solve both of these, we would get s equals how much in this first one? Negative 40 meters. This one would be s equals negative positive 30. Okay, now, in the context of this problem, do both of these answers work?
No, it's a square.
Yeah,
We have a negative 40 meters for the length of the side of this pasture, or we have 30 meters. Marcy?
No, I have a question.
Go ahead.
For 1,200, you crossed out 2 of the zeros.
I did.
But in 10, there's only 1 zero.
That's true.
So why would you cross out both zeros?
Okay, so let's see. How can I explain this? What is 70? Let's say we're dealing with the number 70 and 30.
Yeah.
What is 70 minus 30? 40. So we're looking at if we're doing the adding versus multiplying thing, right? There's 1 0 in all of those when we add them together or subtract them, right? But if we multiply 70 by 30, we get 0, 0, 0, 2,100, right? Does that make sense? Okay. So multiplication, you are...
Oh, okay, because you added the zeros back onto the 3
Yeah.
and 4 instead of...
Yeah, right. Okay. So, you guys tell me, Lydia. Okay, we can't have, everybody give it up for Lydia. Let me repeat. So she said, we can't have, I think this is what she said, we can't have a negative length of something. It doesn't work. You can walk in a negative direction, you can have a negative attitude, but you can't have a negative length of a side. Yes, working with teenagers, something I see a lot. Negativity. Questions on this? So the original length of the pasture has is a square with side length 30 meters. Yes, Lydia. That's it. What? Same thing.
You have 2 positives.
2 positives, 4. I'm sorry. You gotta work with me on as far as what you're talking about.
So if you have positive 40...
Oh, here. Yeah. So it is possible to have 2. Okay. Although in these types of problems, that's probably not going to happen. If you have 2 positives, one of them may work in the original scenario and the other one not in the other scenario. You would go back and test to make sure that it works for both. Okay, other questions? Yeah. Stacey. What's that? Good. Nicely done. Everybody give it up for Stacy. She plugged it in and it worked. Very good. Oh, for me. Oh. Okay. I'm super out of it. Honestly, I need my popcorn. I haven't had popcorn today. I'm running low on energy. Katie! Am I going to get what? Butcher paper. Okay, somebody just needs to remind me so you can go after we finish our notes.
I do it right now.
Not right now. No, I want you to see this example. But So, it's all up to you guys. If someone reminds me, then we will have you go get it right after our notes. Okay, here we go. A rectangular carpet is 8 feet wide and 10 feet long. Who can come up and draw it? Maxie / Marcy. Marcy, come on up. Everybody give Marcy a round of applause for coming up to show us how to draw this. What?
No, I'm just
Comma. Yeah. Okay, while she's drawing this, how many people are tired today? How many people would like to take a little nap? And how many people wish that we could have nap time back within the school day? Do you guys remember that? Like in 2nd grade? Oh, so nice. Yeah, keep drawing. Okay. Yeah.
Whoa.
So-
We just had a democracy in this class, guys.
Okay, so, do you guys, did I tell you my nap story?
there's a border.
There was so a couple of years ago, I think it was my 7th period class got very upset and they really wanted to take a nap. So, one day, I said, okay, as soon as we're done with our lesson, if you guys would like to take a nap, we can take a nap. Did we talk about this in here?
No.
So we did it. We took a little nap. But do you know what happened? No. No. Nobody walked in.
Nobody woke up.
Nobody took a nap. Everybody started talking to each other. So, no more nap time.
So that whole conversation was just a tease. We'll get nap time.
It's not a tease. This is how laws are created in life. You try something out.
Since it's the carpet and not yet.
Okay, everybody give it up for Marcy.
That was because it was 7 p.m. They were actually on the way.
Everybody give it up for Marcy. Okay. All right, time out. How many people agree with this picture? So, a rectangular carpet. A rectangular carpet is 8 feet wide and 10 feet long. Around the carpet is a wood border of uniform width. So, how many people agree that the 8 feet and the 10 feet are in the correct place?
No.
Where should they be? They switched in what way? The inside. Good. It's okay. No big deal.
What is the uniform border?
All right, good question. It's exactly what you drew. So what did you draw? What does uniform mean? Based on, Marcy drew a uniform border up here. What is a uniform border? If you had to describe it based on the picture that she drew, what is a uniform border? The same as the inside. Okay. Sort of. Stephanie? Okay, right. So it's the same all the way around. That's what uniform means. Cool. Give it up for Stephanie. Okay, it's the same all the way around. Here we go. Yes. Okay, you guys, quiet, please. Quiet. No. So what that means is that this width in here, that is the same all the way around. This. Yes. Inside of the border.
Wait, so if it was 8 and 10, it'd be like 10 and 12 for the border?
Yes, something like that. So we don't know that width, so let's call that distance X. I'm making the executive decision. So this, you guys just told me that that distance does not change all the way around, so it's X all the way around, correct? Okay, I'm going to keep drawing these. There's a reason for that. X and X. Okay, now, if we're told that the area of the border all the way around is 63 feet squared, are you guys paying attention over there? Pay attention. Jared?
Well, if it was the same all the way around, wouldn't there not be corners? Wouldn't the corners be like...
No, not necessarily. Okay, because if you think about attaching, so it's just like they come in and there's an angle here. If you think back to triangles from geometry, Think 45, 45, 90 triangles. And that length is the square root of 2 times the length of the other parts. Yeah, that's all. It's cut on an angle, so but it's still uniform width. Okay. Here we go. How many people feel like they can do their homework on their own? And we can stop this problem. Okay, so then stop talking and pay attention. All right, so this length, if we start and we know that this side is 8 feet and that both of these little pieces are x long, then the whole distance of from here to here is 8 feet plus this x plus that x, which is 2x. Raise your hand if that makes sense to you, what I just did on the board. Okay, everybody pay attention. Pay attention. If this distance is 8 feet long, and this little part is x, and that little part is x, then the whole distance from here to here is 8 plus x, or 8 plus 2x. Does that make sense? Okay, how about this side? We do the same kind of a thing, Akashni. 10 plus what? Good, 10 plus 2x. Okay, now, we are told that the area of the wood border, just the wood border, is 63 feet squared. So how would we, if we're given that, you guys told me that the way to find the area of a rectangle is length times width. So the area of this whole thing all the way around is 8 plus 2x times 10 plus 2x. If we subtract out the inside rectangle, which is 10 times 8, then we should get the area of the wood border, which it says is 63. Let me pause this for a second and let you all process that, okay? This represents the area of the combined area of the border and the carpet. And then what you're doing is you're subtracting out the area of the carpet to get the area of the border, right? Does that make sense? Okay, so if we go through and FOIL all of this out, get 0 by itself on one side, that's the same, we're going in that same direction. Okay, so this, when we FOIL it out, is 80 plus 20x plus 16x is 36x plus 4x squared minus 80 equals 63. All right, so when we go through and combine like terms, 80 minus 80, those cancel out. I'm going to put this in descending order, so we get 4x squared plus 36x equals 63. And then if we want to get 0 on one side, we're going to subtract 63 from both sides. So 4x squared plus 36x minus 63 equals 0. Okay, so then we can go through. I'm going to suggest that you guys use calculators on this one because these numbers tend to get a little bit large when we're dealing with these. So we get negative 252 at the top and 36 at the bottom. The two numbers that work in here are 42 and negative 6. And then we distribute the 4x here and the 4x here and reduce. Bless you. So this reduces to 2x and negative 3. And this one reduces to 2x and 21. So we get 2x plus 21 times 2x minus 3 equals 0. All right, so when we solve this one for x, we get x equals negative 21 halves feet. And this one is x equals 3 halves feet, which is the same thing as 1.5 foot. Okay, so in the context of this problem, is there one that does not make sense? The negative one. So we can cancel that out. So the length of the border is the width of the border is 1.5 feet. Okay, questions on this? Yes.
Will both the answers ever be negative?
Will both answers what?
Ever be negative?
That should not happen, no. Other question? Now, you might get 2 negatives, but not in the context of a problem where 2 negatives wouldn't make sense. Like, you could get something like, find 2 numbers whose sum is this, and sum of squares is whatever. And so that, you could have 2 negatives, but not this. All right, so you guys have a homework assignment and a group test tomorrow. Everybody study for that.